The Wright brothers proved, early in the 20th century, that heavier-than-air powered flight was indeed possible. The 20th century was a time of technological advancement and warfare. The race was on between the powers of the world to create better and stronger weapons. One of these advancements was the development of the aeroplane. As the aviation industry began to get off the ground, most aircraft were biplane configurations, with two wings stacked on top of each other due to the limitations of engines at the time. However, as power plants for aircraft grew larger and stronger, engineers began to transition designs to ones with only one singular wing, otherwise known as monoplanes. This allowed for higher speeds and lower amounts of drag from wing struts. As plane engines began to grow stronger and stronger, engineers were forced to find more and more ways to increase efficiency in their designs. One such method was the development of folding landing gears. Most designs up to this point had featured a fixed landing gear, which induced drag at higher speeds. The first aircraft widely adopted that had this feature was the SBD-3 Dauntless, adopted by the United States in 1940 as a carrier heavy fighter, torpedo bomber, and dive bomber. As engineers found that more performance was required in order to move more and more ordnance, they looked at strapping multiple strong engines onto one single airframe. This advancement allowed for an improved range and a massive increase in deliverable payload without impacting speed or max operating altitude. For example, pictured here is a PBJ-1H. With its twin-engine design, it is capable of carrying over 1 ton of explosives, 8 50 caliber machine guns, and a 75mm howitzer, all in the same package, for the intent of striking ground targets. The revolutionary development that would forever change the landscape of the airplane was the jet engine and the solid fuel rocket. The first to be invented was the rocket. The Messerschmitt 163 was one of the first planes to be powered by such a rocket engine. Later, engineers developed the groundbreaking jet engine. A jet engine works by intaking air through a fan, then compressing that air and injecting fuel. The fuel is then combusted, creating thrust. Jet engines were a powerful advancement because of the way that jet engines push the boundaries of speed not seen before by any propeller aircraft. Aviation technology was pushing new heights during this time period, but designers began to be faced with a new problem. The altitudes being flown at had too low an air density for proper breathing. Designers solved this problem by creating cabins that were pressurized to maintain normal air pressure.
As soon as the radio operator gets in, he climbs back to close the pressure door between the forward compartment and the forward bomb bay. The bombardier is the last one in, so he closes the hatch. The gunners close the pressure doors in their compartment. They also open the cabin pressure valves, which will now automatically maintain the cabin pressure at the desired level.
These new planes were designed to be airtight and reinforced to withstand the force created by the pressure differential. One of the very first aircraft to have a pressurized cabin for its crew was the B-29 Superfortress. It was intended to fly at incredibly high altitudes, which necessitated the pressurized cabin. Before the invention of the pressurized cabins, pilots were forced to wear oxygen masks in flying at high altitudes, otherwise risking oxygen starvation. The effects of this invention are still felt today. For example, modern commercial jetliners still use pressurized cabins for the comfort of their passengers and for their crew. Shown here is an immediate post-war example of that commercial use of the pressurized cabin.
And they fly so high that more air and oxygen must be added to the air in the cabin so that the passengers will be able to breathe comfortably. Before takeoff, the hostesses explain the use of supplementary oxygen equipment. Miss Murray points to the backs of the seats where oxygen masks are kept.
Oxygen supply.
She shows how to use the masks in case the air in the cabin should drop below normal
Place
pressure.
the mask over your nose and mouth and adjust the headband.